All right, let's go ahead and do a couple questions here for our quadrilateral coordinate geometry. So we're actually going to start off right here. It says determine whether parallelogram ABCD is a rhombus, a rectangle, or a square for the following points, and we need to list all that apply. So we got A, B, C, and D here. We're trying to figure out whether or not this is a rectangle, a rhombus, or a square. So in order to do that here, what I want to do is I want to go ahead and check out our cheat sheet. On our cheat sheet here, I see if we look at rhombus and squares here, it looks like they have a common goal here. Diagonal slopes must be negative reciprocals. So in a rhombus and in a square, the diagonal slopes will be negative reciprocals. So what I'm going to do here is I'm going to test that first. Because if I test that, and let's say, for example, it doesn't work out, well, then I know that it is neither a rhombus nor a square. Which lead me to believe that it must be some sort of rectangle. But if we do have this and it does work out, our diagonal slopes are negative reciprocals, then what we're going to do is we're going to test to see if it's also a square by looking at the distance of those diagonals. So first off, check here to see if our diagonals are negative reciprocals. Then check the distance to see if they are congruent, see if we have a square. So let's go ahead and start off by drawing our diagonals. So AC would be one diagonal, BD, that's our other. We want to see here what the slope of these looks like. So if you cannot remember the slope formula, that is M equals the rise over the run, or our y's over our x. So y2 minus y1 over x2 minus x1. Starting off here, I will start with AC. And AC is -2, -1, and 3, 2. So by finding the slopes here, x1, y1, x2, y2, so this is going to be M equals our y2, 2 minus a -1, or 2 plus 1, and 3 minus a -2, or 3 plus 2. So when we condense this here, this is going to be 3 on top, 3 minus -2 on the bottom. Going to be 5. So our red line here, AC, has a slope of 3/5. AC has a slope of 3/5. I'm going to go ahead and erase this to give us some room here. So AC with a slope of 3/5. Now let's go ahead and check out BD. BD, so that would be -1, 3. And 2, -2. So again, label x1, y1, x2, y2. And go ahead and plug those in. So -2 minus 3, or y2 minus our y1. And I'm going to go ahead and change this to 2 minus a -1. I would change that to 2 plus 1. All right, so -2 minus 3. That's going to give us a -5. Sorry about that. -5, 2 plus 1 there is going to give us a +3. So our slope here for BD is a -5/3. -5/3. So when I put these two slopes here together, it is very easy to see that these are, in fact, negative reciprocals. So we have a +3/5 and -5/3. Those are negative reciprocals. So I know this is either going to be a square or a rhombus or both. Right now we know this could be a square or a rhombus because the diagonals are negative reciprocals. Now let's go back to our chart here. If we wanted to see if this was a square as well as a rhombus, we know that it's a rhombus because that's the only thing we need in order for this to be a rhombus. We need those diagonal slopes to be negative reciprocals. This could also be a rhombus and a square if the distance of the diagonals are congruent. So let's now go ahead and check the distance. Go ahead and check the distance here. So for those of us that do not remember distance formula, the square root, x2 minus x1 squared plus y2 minus y1 squared. All right, so we will plug that in. Again, we need to find the distance here. So we would start with AC, and I'm going to go ahead and plug in all of our points. So AC here, if I said A was x1, y1, C was x2, y2, this is going to be our x2 minus our x1, so 3 minus a -2, or 3 plus 2. And y2, 2 minus a negative 1, or 2 plus 1 squared. So here, this is going to be 5 squared plus 3 squared, which is also the same thing as 25 plus 9. So we are going to get here the square root of 34 for AC, square root of 34. So I'm not going to reduce that. I'm just going to leave that as it is, because all we're trying to do is we're trying to see if this is the exact same square root as the other one, as the other diagonal. So if these are two different numbers in square roots, I know that those must be different. So AC, square root of 34. Let's go ahead and find BD now. B, x1, y1, D, x2, y2. So here, putting those in the formula, this is going to be x2 minus x1. So 2 minus a negative 1, or 2 plus 1. Y2 minus y1. Sorry, I just realized I said x1, y2. I should be x1, y1. And y2 minus y1 there, negative 2 minus 3. Negative 2 minus 3. Alrighty, now simplifying here, 2 plus 1, that gives us 3 squared. Negative 2 minus 3, and negative 5 squared. So hopefully you guys can see from here, we know we had 3 and 5 in the last one as well. That's going to give us 9 and 25, which again gives us the square root of 34. So AC, the square root of 34, BD, the square root of 34, obviously those are congruent. So not only are our slopes negative reciprocals, but our distances are also congruent. So since we know all of this information now, we should be able to make the conclusion that not only is this shape a rhombus, but this shape is also a square. So rhombus and square. And if we were to explain this, we would say diagonals are congruent and perpendicular. Diagonals are congruent and perpendicular. So that tells us that this is a square and a rhombus. Next question here, same thing. We're gonna do pretty much the same exact method. We're gonna figure out first, are our diagonals negative reciprocals? Are they perpendicular? Then we're gonna also check out the distance, try to see what we know about that. All right, so starting off here let's go with GE. I'm going to find the slope here of GE, which is between negative 1, 3 and 0, 2. So again, that slope formula, M equals the rise over the run, or the y's over the x's. So go ahead, plug that in. So M is going to equal y2 minus y1. So I'm going to say here negative 2 minus 3 over 0 minus a negative 1, or 0 plus 1. So simplifying this here, negative 5 on top, 1 on the bottom. So our M for GE is going to equal negative 5. M for GE is equal to negative 5. Now let's go ahead and do our other diagonal here, FH. So F x1, y1, H x2, y2. Throw those into our slope formula. So 1 minus a negative 3, or 1 plus 3 on the top. X2 minus x1, 2 minus, oh, I'm sorry about that. Little mistake there. I threw the wrong y. And for y1, y2, 1 minus y1, 0. So 1 minus 0 on top, 2 minus a negative 3, or 2 plus 3 on the bottom. So here we're going to get 1 over 2 plus 3, which is a positive 5. So GE is negative 5, FH, positive 1/5. So hopefully you guys can see here, again, we have some negative reciprocal slopes. So right now, I know that this could be either a square or a rhombus. Those are the two options, square or a rhombus. So let's go ahead and check now and see if our diagonals are congruent. If our diagonals are congruent, then this will be a square and a rhombus. But if our diagonals are not congruent, then this is just going to be a rhombus. So let's go ahead and find the distance here for our points. So distance is going to be, let's start with GE. I'm going to throw this in the distance formula here. So G, I'll call x1, y1. E, I'll call x2, y2. Got to throw in that distance formula, x2 minus x1 squared. So 0 minus and negative 1 squared, or 0 plus 1 squared. Y2 minus y1 is going to be negative 2 minus 3 squared. So simplifying this here, we get 1 squared plus negative 5 squared, which is just going to be 1 plus 25, which gives us the square root of 26. So for GE here, GE is going to equal the square root of 26. Square root of 26. Now let's go ahead and do FH. So F here, I'll call F my x1, y1. I'll call H my x2, y2. Throwing them into this formula here, 2 minus a negative 3, or 2 plus 3 squared. Y2, 1 minus our y1, 0 squared. So 2 plus 3 squared plus 1 minus 0 squared. This is going to be 5 squared plus 1 squared. As you can see, we're going to get the same exact answer that we did in that first one. This is going to be the square root of 26. So for FH here, we also get the square root of 26. So clearly, our diagonals are not only are they congruent, but they are also perpendicular to each other. Okay, not only are they congruent, but they are also perpendicular to each other. So when you go through these answers here, it's not just a rhombus. So we know it's not that. It's definitely not a rectangle. So since it's not a rectangle, we cannot include C. So A, B, and C are all out of the question here. It's actually going to be D. It's none of these options. Okay, it's none of these options. This is a rhombus, and this is a square. So this would be none of them. Last one here. Got quadrilateral ABCD. We got vertices 5, 1, negative 3, negative 1, negative 2, 3, and 2, 4. We're trying to show that ABCD is a trapezoid. We're trying to determine whether or not it is an isosceles trapezoid. So let's go over to our cheat sheet here and check out what we said about trapezoids. So the top and the bottom slopes have to be the same, and the slopes of the legs must be different. So in order to test that, we can go ahead and figure out if these top and bottom legs are the same. We want those to be the same. And we want our legs, these two green lines here, to be different. All right, doesn't matter how different they are, they just have to be different. So let's go ahead and start by doing the top and the bottom. So got to find the slope here of CD, slope of CD. And again, I'll write that slope formula for you. Y2 minus Y1 over X2 minus X1. So CD, starting off, is going to be Y2 minus Y1. So 4 minus 3 over 2 minus negative 2, or 2 plus 2. So when we do that, CD, 4 minus 3 is 1. 2 plus 2 is 4. So we get a slope of 1/4 here for CD. Now we have to do BA. So again, starting off with Y2, we're going to start with 1 minus a negative 1, so 1 plus 1, and 5 minus a negative 3, or 5 plus 3. So here we are going to get 2 over 8, which hopefully you guys realize reduces to 1 over 4. So our top and our bottom slopes are the same, so those check off. Now we've got to check out our legs. If our legs are different, then we can confirm that this is a trapezoid. So we need to figure out here the slope of BC as well as the slope of AD. All right, so starting off with BC here, if I make B my x1, y1, this is going to be -1. 3 minus a -1, so 3 plus 1. And C, we're going to start with -2 minus a -3, -2 plus 3. So reducing 3 plus 1 here gives us 4. -2 plus 3 gives us 1. So BC is a slope of 4. Now for AD. AD here, I'm going to make A my x1, y1. So starting with D, we're going to say y2 is 4 minus y1 is 1. x2, 2 minus x1, which is 5. So when we reduce this here, 4 minus 1 is 3. 2 minus 5 is -3. So we get a slope here of -1. So as you can see, 4, -1, those are not the same slope, which means they are not parallel to each other. So we can check off that box as well. So everything we have just done tells us that this is, in fact, a trapezoid. Yes, this is a trapezoid. Now we got to ask ourselves, is this an isosceles trapezoid? Isosceles trapezoid or no? So let's go back to our cheat sheet here. If we wanted to test if this was an isosceles trapezoid, the top and the bottom slopes must be the same, which they are. We just tested that. And the distance of the diagonals must be congruent. The distance of the diagonals must be congruent. So I'm going to clear some of this up here just so we can have some room to see what's going on. And in order for this to be an isosceles trapezoid, these two diagonals here have to be congruent. Okay, so we got to take the segment BD, figure out what the distance of that would be, figure out the distance then of CA. All right, so I'm going to start off with BD, x1, y1, x2, y2. Throw that into the distance formula. So x2 minus x1 is going to give us 2 minus -3, or 2 plus 3 squared, plus y2 minus y1, 4 minus -1, or 4 plus 1 squared. So when I do this here, this is going to be 5 squared plus 5 squared, which is 25 plus 25. So for BD here, we're going to get the square root of 50. Square root of 50. And again, I don't need to really take that square root, figure out what that exact number is, because I just need to see if we are getting the same square root for both diagonals. So that's just one less step we have to worry about here. Now let's go ahead and find AC. So AC, I'll say A is my x1, y1. C is my x2, y2. Throw that in our distance formula. So starting off, x2 minus x1, -2 minus 5 squared, plus y2 minus y1, 3 minus 1 squared. So here, -2 minus 5 gives us -7 squared. And 3 minus 1, that gives us 2 squared. So here, this is going to be 49 plus 4, which is the square root of 53. So hopefully you guys can tell here, judging by our work so far, our first square root was the square root of 50. Our second square root was the square root of 53. So these are not the same. So our diagonals are not congruent, which tells us no, this is not an isosceles trapezoid.